I would like to give a brief introduction into the evolution of the design, and I want to point out sort of the key main steps we did at the very beginning. Obviously green and architecture items, they are related and they inform each other, but I want to point out the key steps from an architecture point at the very beginning and then hand over to my team colleagues who will talk more about the green aspects of the building. The original Joseph Urban building was designed in 1928, and Joseph Urban was an architect from Vienna who did a lot of theatre and opera set designs. If you go one back, please. You see this building on 55th and 8th Avenue, which is it has a very Art Deco proportions and has very distinct columns here as an ornament. It was a 6-story structure, but what is most interesting about the building, it was meant to be the base of a future tower. And building in faces was a very common pattern in New York in the 20s. And both, as you see, the Standard Life building and the Singer building, they were both perceived as face projects with a base and a future edition of the tower. Joseph Urban had an associate architect, George Hearst, and he proposed his own scheme in 1945. There's no drawing, there's no existing drawing which shows what the original tower would have looked like, but his associate architect, George Hearst, had a go, if you like, this in 1945 and proposed a 9-story addition, which you see over here, which is a massive addition. It's very wide. You see even some of these columns have been removed in the process. And whenever I see this image, I'm wondering what our associate architect Adamson's will do in the future. When we got involved, as you see in the next diagram, you see the evolution, the tower and the base. This was the as-of-right area, 726,000 square feet, which was available back then. And you see in the next slide, you will see the 3D model, which shows the zoning envelope. As you probably know, in New York, you're most likely not to be limited by height, but you're limited by the area you can build on the site. So we studied this envelope, this daylight setback envelope, very carefully, and in yellow you see this envelope within one can build. What is interesting about the site is that you see to the left, you see the Sheffield building, which is adjacent to our site from the west, and you see the dark, you see the site, you see the dark, very dark zone in the middle, which would be a central core scheme. And you see in orange, you see an area which really hasn't got any daylight, and therefore hasn't got any windows because of the adjacent building. So what we felt was necessary is to move the core to the west. And this really does two things. In the core with the staircases and the elevator, we don't need the windows, and also it opens up the area to the east and has a far more flexible floor plate here to the east where you see the arrow. As a result of that, when you move the core, the building, which is shown in the next slide, the building became unstable in terms of lateral wind forces, and particularly on the east face, because the core helps to stabilize the whole building. If you move it to one side, it became unstable on that side, and our structural engineer came to Sanic advised we need some kind of bracing, a diagonal bracing, or either moment frame on this east elevation. So for the next few months, we were running with two different schemes, one being a scheme where you have a diagonal bracing, which we called subsequently the diagrid, second being a moment frame. And you see that in the next image, both of those. And the moment frame on the left is the moment frame means you have very stiff corners, and this gives you the stability. The diagrid, which we developed, means that you don't have any vertical columns on the outside on the perimeter of the building. And when we both compared both schemes, as was mentioned in the introduction, It turned out that the die-grid scheme uses 20% less steel, and we found that very compelling, particularly in regards to lead. And also we found the die-grid scheme at this stage we felt has probably more potential for this particular site. Next. This shows the evolution again. On the left is the massing. We developed the die-grid based on a 4-story structure, and only when we did the 4-story structure, the setup, we realized when we built a physical model, we realized that there's no vertical column in the corner, and therefore the potential to carve out the column what you see on the right and to articulate these corners. What's interesting about the corners, there were really two aspects in this design process which we found very intriguing, which really helped us on the way when we had to make these decisions. One thing we felt, being new in New York City, we felt what is really interesting about the city is the grid and the streets, and that you often, from a street level, you hardly see a full elevation of the building. What you really see of the building in New York is always the corners. That we had this in mind, and when we came to this point, when we had to make a decision, we found, well, this is the right thing to really put the emphasis on that building into the corners. The second, and this diagram is showing that the second aspect of the corner is the corners usually are the most valuable space in an office tower, and particularly on this side, and you see some of the images later on, this side offers great views from the corner to Central Park, and we felt by actually cutting or chamfering the corners and cutting those corners back, we increase the glass area at the corner, if you like, and make these offices even more valuable. This shows a floor plate, and as it developed a low-rise plan in this case. You see the core is moved to the left. You see you have cellular offices on the north and south side, and the east side is open workstations. But what is important, that all the corners in the typical floors, they all remain either meeting or working spaces. So for each magazine which will occupy the floors, everyone has access to the corners. And that's one image which we found very helpful, which we did at the very beginning. We didn't know what all these materials are, and as architects we tried to communicate an idea, and that was something which we did. It's a very simple 3-dimensional sketch, which actually doesn't show much architecture at all, but it emphasizes the geometry of the corner and the view and the potential of this project. And that was very much an image which helped to convince ourselves, and then helped us to convince others to go down this route. And it will be interesting to see now, as we approach a good stage with the fit out, to see how this translated into the real image. Now, in this evolution, the next big step we took was, we felt very strongly that we wanted to separate the old and the new, and therefore we lifted the tower by 10 stories, and only the structure and the elevators could go through. And we wanted to make this separation between the old and the new. We wanted to make this, that people experience that from the street level, so we had to find the right datum level where we set level 10, so people walking around the streets could actually experience this separation. And then as a final step, what was a big step for us is we wanted to make the lobby special, and it was the floor plate. The floor plates in the existing building were 11 feet floor to floor, which isn't enough for a modern office space. So we removed the top floor plates and used the area and transferred the area to the top of the tower where it's more valuable, and also allowing then in the lobby have a greater potential by keeping the facade to do something, have a bigger volume and do something spectacular. Again, this is the portion which was removed inside. And this is the lobby as it came together. You see the entrance is at street level. People rise 2 levels up the escalator through the water feature onto the main lobby level, which will be level 3. And then you see the tower rising from level 10. Brian mentioned some of the cost-effective measures, but the lobby isn't certainly one of them. Shot as it was a few months ago. That's an image as people will experience this ride through with the escalator through the water And the relation, interesting, the relation seeing as well, if you are in the lobby, if you're in the corner of this new space for Hearst, which will house a cafeteria, an auditorium, a kitchen, which will be really a very, very different space to what Hearst is used to at the moment. We will think it will inform, hopefully, will inform the people now will enjoy the space, and all the employees will enjoy the space. It's a very open, very light space. And you also see from certain angles within the in lobby space, you can see the tower rising above, which that image shows. Inside the lobby, you see the structure coming down. It's clad in stainless steel, the same material is used for the outside cladding. And again, the view from street level ensuring the separation and the relation between the old and the new. And finally, the top of the building is something we feel will be a fantastic space, and we're working with Gensler for the fit out, and Bob Sartz is here tonight as well. And Alex, if you go to the next image, that's the very top floor is a very special. There are going to be 3-story high spaces and offer a great opportunity for Hearst to come together and then celebrate the space and enjoy the views. And Brian told us earlier, and I mentioned that before, but Brian told us that Hearst already have booking for the space, but it's not been built. But we hope to get this soon.